Hello and welcome. In this video, I'm going to complete a series of tasks about BGP on OcNOS devices. The task list includes configuring ebgp peering between some of the devices. Some of them are going to be IPv4 and IPv6, and some of them only IPv4. I'm going to start with the second one. Then I'm going to advertise some loopback interfaces into the BGP table, and then I'm going to test the connectivity and reachability of them. If there is a reachability problem, I have multiple options. Two of them, of course, are here: next up self and redistribution. But of course, there are some other options that we can discuss in later videos. But for now, let's just check the ebgp peering between some of the devices. The topology consists of multiple autonomous systems. For now, the autonomous system that we are interested in is autonomous system AS200. I'm going to create an ebgp adjacency between router 1 in AS100 and router 8 in AS200. Later, of course, I'm going to change the configuration to confederation in AS100, but for now, I'm just going to assume that router 1 is a normal router, not inside the confederation. And also here, router 16 is the only router, which later I'm going to configure this as a PE for the MPLS network. But for now, of course, this is going to be only a simple adjacency between the two ASs. So let's just start from the connection between router 1 and router 8. Because it's an ebgp adjacency, I'm going to configure this using the update sources of the ports themselves. When you do not specify an update source, what is going to happen is the actual port connecting these two is going to be used as the update source, and that is a good option, as a matter of fact, for different reasons. The first one, most of the time we have a direct connection. We do not really want to use loopback interfaces to create this. ebgp is going to set the TTL of the packet by default to 1. You can increase it, you can create adjacencies using loopbacks, but most of the time when you use loopback, you want to use multiple paths to the destination, and that is the most important reason. But there are some other security issues that you do not really want to go through multiple hops to get to the destination. Otherwise, you could just do the configuration. It is completely doable. But let's do this in a very simple way. On router 1, I have configured the necessary IP addresses for the interfaces. But for now, let's say that I'm going to configure this on the router BGP 100. I can just go with BGP router ID of 1111, and I can just say neighbor, and the neighbor which is adjacent to me is going to be 10.188, which is in remote AS 200. When your BGP autonomous system is different from the autonomous system of the neighbor, this is going to create an ebgp neighbor. And because I'm not doing anything for update source, this is going to be used for the update. So 10.181 is going to be used as the update source. And address family, of course, IPv4 unicast is going to have this neighbor activated. So I'm going to make sure that activate is going to be there. Also, I have to advertise the network, and the network is going to be 1111/32. And of course, I have 111.11/32. I can just go with both of them for now. That's okay. So I'm going to commit the configuration, and then if I say do show IP BGP, you can see that I have these in my BGP table. And if I say IP BGP summary, for now says that this is active. Let me just end. What I'm going to do is to say terminal width is going to be 256, and do this command one more time, and of course without do. Okay, so we have this, and we are going to wait for this to come up. After, of course, I have configured router 8, OcNOS for the username and password, configure terminal, and on the router BGP 200, which I have configured before, what I'm going to do is to say neighbor is going to be 10.1.8.1, which is in remote AS 100, and nothing more than that. So I go under address family IPv4 unicast, and under this I'm going to activate this neighbor. So I just type activate, and then I'm going to commit the configuration, and of course I should save it because I really want to. Going back to here, what I'm going to do is first of all to save the configuration, and then I'm going to check show IP BGP summary. Right now you can see that I am in adjacency with this neighbor, and as you can see there are 3 prefixes that are transmitted. So let's check them. If I just say show IP BGP, you can see that I have access to 9999, 10, 10, 10, 10, 11, 11, 11, 11. So I am in adjacency with router 8 as a matter of fact. Let's show running config of router BGP, and as you can see I have advertised these. So after some time I should see these in my BGP routing table, and there is this. Okay, so let's just take a look at one of these in detail. For example, this 9999. So I'm going to say show IP BGP 9999/32, and this tells me that for now the next hop is 10.1.8.8, which is reachable, and I know about that because I am directly connected to that, and I can get to the destination. So do I have it in my routing table or no? So I would say show IP route 9999, and based on what I told you, this is installed in my routing table as a BGP route with a distance of 20 and a metric of 0. Okay, very nice. So let's see if we can ping it. If I try to ping 9999, the ping doesn't go through. The reason? Because the other side doesn't know about me. Okay, I need to fix this problem. So I'm going to stop this, and then I'm going to go to router 8. Now on router 8, what I'm going to do is to say show IP BGP. And an IP BGP says that, okay, we have access to 1111. Let's go back to router 1 and do this ping using a source of 1111 and see if this is going to go through. Again, the same problem. I do not I know how to reach to this address, but this address doesn't know how to reach back to me. Let's see if this is the case with 8888, because that is my neighbor directly connected to me. So if I try this, 8888 has no problem, but 9999 of course has a problem. So let's go back to router 8 and check this. When we have show IP BGP 1111, you can see that it says I know about the next hop. What I need to do is to get to this IP address 10.1.8.1, which is my next hop, and I can get to the destination. Does router 9 know the same thing? I go to router 9 and I'm going to check my IP BGP. So I go to here and say en show IP BGP, and it says that, okay, I don't know anything about 1111. I have not installed it here because maybe there are some problems. Let's see if router 10, which is a route reflector, knows about that. So let's go to route reflector here, OcNOS, and I'm going to say show IP BGP. Okay, router 10 knows about this, but it doesn't believe that this is the best prefix, because it doesn't, we don't see this greater than sign in front of that. Now if I just say show IP BGP and after that this prefix, it says that it is inaccessible. So the reason, I don't know anything about how to get to 10.1.8.1. Okay, so you know that this is an IGP problem. So if I just say show IP route for 10.1.8.1, it says there is no such network in my table. Okay, so let's go back to R8 and see what we have in our IGP. So if I say show run router OSPF, Under this, you can see that I have advertised some of the networks, but not that specific network. So 10.181 is not here. So how can I solve this problem? So what I'm going to say is router 8 is going to configure router 10 and router 11 in such a way that anything that it receives is going to change the next hop to itself. So for now, let's go to router 10. If I say show IP BGP 111.1 and see that it says that next hop is set to 10.181, but now if I just go back to router 8 and say I'm going to exit this address family and I'm going to say neighbor 10.10.10.10, next hop is going to be this should be under address family as a matter of fact, so I'm going to do that. IPv4 unicast, and I'm going to say neighbor 10.10.10.10 is going to be configured with next hop self, and after that hit enter. Neighbor 11.11.11.11 is going to be configured with next hop self and hit enter. I'm going to commit this, and then I'm going to end and of course save it because I want to see something. What I'm going to say now is show IP BGP 1111. So you see that it says the next hop is right now 10.181. Okay. So if I say show IP BGP neighbor, and for this neighbor 10.10.10.10, I'm going to see what am I advertising. If I say advertise routes, you can see that everything that I'm sending has been set with the next hop as 8888, which is interesting because this is exactly what we wanted to do. So this is going to get to router 10 with this next hop. So let's check router 10. On router 10, I'm going to say previously we had this next hop, right? If I just try this one more time, this time it says next hop is 8888. Interesting. So if I just say show IP BGP, now I don't have the problem of unreachability here. And it doesn't say inaccessible. As a matter of fact, it says that this is completely selected and it is the best one. Okay, let's go to router 9. Router 9 is another client of Route Reflector. And if I just say OcNOS here for username and password and go to here, then I'm going to say show IP BGP. Now you can see that I have, as a matter of fact, two paths to get to the destination. One of them is through router 10 and one of them through router 11. Both of them have been advertised to me. And let's just go with a little more specific prefix here. It says that the next hop is set to 8888. Now let's go back to the topology and do the second part. I'm going to configure connectivity between router 11 and 16. Again, IP address configuration of R16 is there. So let's go to R16 and say OcNOS. If I see show IP interface brief, I have Ethernet and also a loopback configured. EN configure terminal. And the autonomous system number here is 300. So I'm going to say router BGP 300. I'm going to say neighbor is 10, 11, 16, 16, 11 of course, which is in remote AES 200. Is going to be my neighbor, and address family IPv4 unicast. I'm going to say this neighbor should be activated. And also I'm going to advertise a network which is 16.16.16.16/32. So I'm going to commit the configuration. On router 11, I'm going to go back to router BGP 200. I'm going to say neighbor 10, 11, 16, 16 is in remote AES 300. And under the address family, I'm going to say IPv4 unicast. And I'm going to add this neighbor and activate it. So activation is done, committing is done, and now let's see what we have. Okay, so on R16, I'm going to say show IP BGP. Here it is. We have our own BGP, but let's see, show IP BGP summary. Here it says that it is still idle. Let me just change the terminal width to 256. And the reason might be this. I have 10.11.16.11, which is in AS200, and I am in AS300, and rather 11. I am in AS200. The remote AS is this, and 16.16. Show IP BGP summary. This is it. Says that it is 256. Okay, so let me do it one more time. And it still says that it is idle. So let me see if I can reach to this using a ping. So if I say ping this, okay, maybe IP address is not assigned. Show IP interface brief, and that's a problem. Okay, so the interface for that is Ethernet 3, which I need to configure it right now, which is super simple and fast. Interface ETH3, IP address is going to be 10.11.16.11/24. And I'm not advertising this on their OSPF or anything. So let's go to here and check the adjacency now. So if I just go back to here, it says that now adjacency is done. And if I go to router 16, if I say show IP BGP, these are the prefixes that I have received. But can I reach to them? Can I reach to 8888? If I say ping 8888, and the source IP is going to be 16.16.16.16, the ping doesn't go through. Why? The other side doesn't know anything about me. So let's go to router 8. If I say OcNOS for username and password and say show IP BGP, the thing is 16.16.16.16 has the same problem. This time I'm going to solve it in another way. This time I'm going to, advertise this using redistribution into OSPF. So that is going to help me make sure that I have reachability to the destination. So let's do this. I'm going to go to router 11. And on router 11, this is running configuration of my OSPF. So what I'm trying to do is to go to configuration mode. I'm going to create a route map. The name is going to be connected interfaces. And under permit 10, I'm going to match. I can match with an interface that is okay, or I can match with an access list or prefixes. Let's go with interface, which is going to be much better. So that would be ETH3. So I'm going to go to router OSPF1, and then I'm saying redistribute connected subnets and redistribute connected. Just route map is going to be connected interfaces, and after that, that's it. Hit enter. So I'm going to commit this. Now if I go back to router 8 and try this one more time, this time I don't have any problem with that. If I go back to router 16, try the ping this time, ping is going to go through without any problem. And on router 8, router 9, I have full reachability to here. Now the other thing is, can I go multiple autonomous system to get to the destination?
If you check here, from router 16 to router 1, I have to go through router to AS200 and then get to AS100. Is it possible or not? So what I'm trying to say is I'm going to ping router ping 1111, and you can see that the reachability is there without any problem. So we did the ebgp peering. That was of course a simple peering, but we did it. We used next hop self and redistribution option. Both of them of course were valid. Which one would I take? Of course there is another one using route map. You can change the next hop. That is another option of course, and sometimes you want to use that. Which one is better? There is no better in your design. Which one I would prefer? In my case, of course, redistribution was, I guess, okay to use, but again, these are other options that you can choose to have based on your network connectivity. So that is this, and the tasks are done. I hope this has been informative for you, and see you in next video.